Alright, so what we're going to be doing today is a little podcast on gas laws. Now, the best way to go about doing these problems is follow 5 easy steps. First one being list off all your knowns and what your unknown is. Second off, you're going to want to choose and manipulate an equation from all of the gas laws equations and then change just the variables to solve for what your unknown is. Then third off, you want to substitute all your knowns into that equation, and then you're going to solve it. And then after you do all that, the best thing you can do is to go back and make sure that your answer makes sense, because if it doesn't, it means you made some math error somewhere. So the first one that we're going to do is Avogadro's law, which is V1, which is volume, over N1, number of moles, equals V2 over N2. And almost identical to that is Charles' law, which is V1 over T1, temperature, is equal to V2 over T2. Then, we're going to cut that. Alright, then using Charles' law's equation, we could do the problem if a 2-liter sample of air is collected at 298 degrees Kelvin and then cooled. If the new volume is 1.9 liters, what is the temperature of the room? So we start off by listing our knowns and unknowns. There's the equation we're going to use. V1 is equal to 2 liters. T1 is equal to 298 Kelvin. V2 is equal to 1.9 liters. And we're trying to get T2. So we manipulate this equation until we can solve for just T2. And we do that by multiplying by T2 over here, and then we put the T1 on top here and V1 on bottom here, so that what that winds up looking like is V2 T1 over V1 equals T2. So then all that's left to do is plug in our numbers. We have 1.9 liters for V2. T1 is equal to 298 Kelvin. And we put that over V1, which is 2 liters. Plug all that in on your calculator, and we get 283 Kelvin, which is the temperature of the room after it's cooled. Okay, the next 2 equations that we're going to do are going to be Boyle's law and the ideal gas law. These are a little easier than the other ones. So Boyle's law is going to be P1 times V1, pressure times volume, equals P2 V2. And the ideal gas law is going to be P, pressure times volume, is equal to M moles, R, which is a constant that somebody with too much time on their hands thought of, times temperature. And this constant is, I don't know if Mrs. Weber wants you to memorize this or not. I don't think so. But R is equal to 0.08206 liters times ATM, atmospheres, which is a unit of pressure, all over Kelvin moles. That is R. And this ideal gas law equation is one that you're going to have to do a lot in your homework. And this one is used more than all the other ones. Okay, and then a usual problem that you're going to see using the ideal gas law is that a sample of hydrogen gas, H2, has a volume of 8.56 liters at 0 degrees Celsius. And a pressure of 1.5 atmospheres. Calculate the number of moles of H2. So, first thing to do is write out your knowns and unknowns. So P is equal to 1.5 atmospheres. V is equal to 8.56 liters. N is what we're trying to solve for. That's in moles. R is equal to the constant 0.08. I'm making mistakes. 8206 liters ATMs Kelvin moles. And then T is equal to, even though it says 0 degrees Celsius in the problem, every single gas law problem has to be in the Kelvin scale, which is really super important. Because if you forget that, you're going to get all the answers wrong. So you have to make sure it's Kelvin, and to get Kelvin, you add 273 to whatever your Celsius degrees is. So since it's 0 degrees Celsius, it's 273 Kelvin. Okay. So now we have this equation, we have to manipulate it to solve for n. So all we do is divide both sides by RT, which is going to give us PV over RT equals n. So now all you have to do is fill in your knowns. So P is equal to 1.5 ATM. V is equal to 8.56 liters. Divide that by 0.8206 liters ATMs Kelvin moles. That one's fun. And multiply that by your 273 Kelvin. And now you can see why the units on R are so messed up, because now they all cancel out to leave moles. This ATM cancels out with that. This liters cancels out with this liters. This Kelvin cancels out with this Kelvin. And then you're just left with moles. So you plug all that into the calculator and you get 0.57 moles of H2. Just in time because my marker's dying. Alright, and those are the 4 basic gas laws that you're going to need to know for this chapter.